Hey guys, and we're back. Let's just dive right in here so we have plenty of time to do all the examples. We are now doing pyramids and cones, and then we'll do one little bit at the end here to help you with the homework. So let's do it. The formula for pyramid is very similar to the volume formula for prism. But instead of just base times height, or sorry, area of the base times height, it's smaller than that by 1/3. So 1/3 area of the base times height of the pyramid. Okay, don't copy down these examples because we're going to skip down to do a nice fun one. Okay, so scroll, there we go, it's a little slow, to number 6 here. All right, and we are going to find the volume of this triangular pyramid. Interesting. All right, so if the formula is 1/3 base area of the base times the height, the first thing we want to focus is the base, right? How do I get area of the base? So the base in this case is going to be this triangular bottom here. This is kind of a weird one because normally you know that the base of a pyramid is the one that is not the triangles, but since the base is also a triangle, you just look at the dimensions. In this case, all of those at the bottom are 10, 10, 10, right? Whereas that height is 16. So that's going to be, since the 16 is different, that tells me that that's the height. And the base is an equilateral triangle, right? So in general, we already know to find the area of a triangle, because that's going to be my capital B, you do 1/2 of base times height. But the base and the height always have to be perpendicular. So a common mistake for this one would be looking at that triangle, which is equilateral, 10 by 10 by 10, and saying, okay, I'll just do base times height, 10 times 10. No. Okay, so all I did is I'm just redrawing this highlighted base right there. Because in order to find the area of that triangle, I need to find the height of it, which is going to be this right here, drawn inside. But since that's an equilateral triangle, there's a special little fact about equilateral triangles. All the angles are 60, which means when I draw in the height, I'm cutting that in half, which is 30. So then you have, that's right, a 30, 60, 90 triangle here, which you should know all of those rules already. So if that whole bottom is 10, that's my base of the triangle. Okay, so we're going to come back to that. This little piece from here to here is just 5. And so based on the rules for 30, 60, 90 triangles, the height has to be 5 square root of 3. Remember the long leg, short leg hypotenuse? Okay, so the height is going to be 5 square root of 3. Let me write that over here. Height of the triangle, not of the pyramid, is 5 square root 3. So that's important. This 10 here is the base of the triangle. So we're going to plug that in, to find this capital B stuff right here. So that's going to be half of 10 times 5 square root 3. Just scoot that over a little bit. No? Okay. Can I? No. Okay. Well, let's keep that in terms of our simple's radical form because Miss Coffee loves simple's radical form. So we do half of 10 is 5. 5 times 5 is 25 square root of 3. So that right there is the area of the base. So then I go back to my formula for volume and I plug it in. 1/3 of 25 square root of 3. And then height is the height of the pyramid. So that is 16, right? Because you can see how it's forming this perpendicular 90-degree angle right there. So therefore I know this has to be the height, this right here. It's your height of the pyramid. All right, okay, so then we type it all in, right? 25 times 16 divided by 3. And your volume is, ooh, that's going to be a fraction. So I'm going to give you multiple options here. 400 square root of 3 over 3. Or you can write that as approximately 133.3 square root 3. Don't like that option very much, but the first one would be the best option in terms of simplest radical form. But if I wanted this rounded, round, like your homework probably wants, then you're just going to multiply that by the square root of 3, and you get approximately 230. Nope, that's wrong. Sorry, I was multiplying the wrong thing. You multiply 400 square root of 3 over 3 times, oh no, that's right, okay, 230.9 centimeters cubed. Okay, we'll leave it as that because probably Pearson's going to want it rounded to the nearest decimal or whole number, but if it says the word round, make sure you're typing in the square root 3. Okay, so this one was a good one because you're using 30, 60, 90 now. So make sure you don't remember, or make sure you don't forget, goodness gracious, the rules for 30, 60, 90 is x square root 3, and 2x. All right. Okay. And then let's move on to cones. Alrighty, so the formula for a cone is very similar again, but instead of having a capital B for area of the base, well, the base is always circular. So it's 1/3 of pi r squared times the height. And so we'll do a real quick example here. Number 9, okay. This is a good example because we have to do a little bit extra work for this one. So volume is pi, 1/3 pi times the radius squared, right? Well, we are not given the radius, we are given the diameter. So you want to make sure that you are finding radius by dividing that by 2. So you can leave it as a fraction or a decimal. I'll do a decimal for now. Well, we'll do decimals for this whole thing because probably going to have a decimal for this next part. And then times the height. Oh dear, but look at that. I do not have the height. So guess what you have to do? You guessed it, our favorite theorem. Dun, 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 dun. So to get that height, let's do Pythagorean theorem over here. H squared plus 13.5 squared equals 22.5 squared. So that's going to be h squared plus 182.25. 22.5 squared is 506.25. Subtract, and, oh, actually this looks nice, 324. And we are going to square root that, which is 18. How nice. So the height is 18. Looky there. So let me just plug that in right here. Okay. And then we solve. First, let's leave it in terms of pi. So 13.5 squared times 18 divided by 3. Do not forget to divide by 3. So 1093.5 pi, or if you're one of those crazy people, no, it's not going to do that because that's a gross one. Okay, we'll leave it as that. That is in terms of pi. Okay. And okay. Sorry. And then if I wanted this rounded to the nearest decimal, then I would do all of that fun stuff. Multiply it by pi. Where's my pi? There it is. And that is 3,435.3 kilometers cubed. So whichever one of those you want. In terms of pi, rounded to the nearest decimal. Okay. Just like cylinders can be oblique, cones can also be oblique. So I'm just going to go back up here and just show you, right? That would be a leaning cone of Pisa. So it would look something weird like this. Well, there's a couple different ways, but basically you could have your, let me exaggerate this a little more actually. Okay, so one way would be like a super duper slanty one. And that would mean your height would go outside right here. Your radius would still be the radius of the circle. Or it could be to where the side of the cone, one of the sides of the cone, is actually already perpendicular to the edge of the circle. So the difference between an oblique cone and what's known as a right cone is that the height, which is still perpendicular to the base, the height in a right cone is going directly to the center of the base. Whereas in an oblique, the height could be outside of the circle, could be inside but not the center, or it could be exactly on the circumference of the base, but it's just not at the center. So that's oblique. Don't be scared by those. Same formula, same process. Okay. So that's it for that. And I think I'm going to need to spend a lot more time, not a lot more time, but more than 3 minutes, going over revolutions, because that is an important part that you need to know for your homework. So I will pause the video here, and you have one more. Hopefully that won't take up the full 15 minutes. Cool. Thanks, guys. You're the best.